So when we talk about inequalities, the first thing we need to understand is interval notation. With interval notation, there's a few symbols we need to be able to use. I'm going to make a table here. This is going to be the inequality symbol. So less than, greater than, less than or equal to, greater than or equal to, and I'm also going to put infinity here, and I'll explain that in just a moment. On your graph, on your line graph, if you don't have the equal to sign, you're going to use an open circle, and if you do have the equal to sign, you're going to use a closed circle. And with infinity or negative infinity, we're just going to have arrows that's going to indicate that on the graph. The last thing is the interval notation. So for example, if you have a less than symbol, you're going to use parentheses. These are like open brackets. And if you have the equal to sign, you're going to use closed brackets. And with infinity, because you can't ever really get there, you're going to use parentheses. So just a quick couple of examples. If you say x is greater than 4, then on your number line, since it's greater than, we're going to use an open circle, and we want to shade to the right. And in interval notation, that would be 4 to infinity. If, for example, you had x is less than or equal to negative 3, because it has the equal to, we're going to put a closed circle, and it's less than, so we're going to shade to the left. And then when we read this from left to right, we're going to go negative infinity up to negative 3, but we want to include that negative 3. One last example. Let's say that I wanted to have x being between 4 and 0. So notice we've got the equal to on the 0, but not on the 4. On the number line, we're going to have an open circle at 4, but a closed circle on 0. And we would shade in between that. And for the interval notation, we'd have a bracket because we're including 0, and then a parenthesis because we're not including 4. So when we solve any inequality, there's really only a couple of differences than solving an equation. The first is if you multiply or divide by a negative value, you have to switch the direction of the inequality. We'll do some examples in a minute. And then second, we don't get x equals 4. We might get x is greater than 4 or less than or equal to 4. So we're going to represent our solution either in what's called set builder notation, which is not very common, or more commonly on a graph or using what we just talked about, interval notation. So let's take a look at a couple of examples. For this first one, we really don't need to think too much about this inequality sign unless we're going to multiply or divide by a negative. So let's start by collecting our x's. So I am going to subtract 8x from each side. So 14 minus 10x is greater than 1. And then I will subtract 14 from each side and get minus 10x is greater than minus 13. So right here, when we divide, we're going to divide by negative 10. And I like to indicate to myself that I need to switch that inequality. So I usually put a circle around it when I'm dividing. And that helps me remember that I get x is less than 13/10. So let's take a look at this all three ways. For set builder notation, we would make a set, and we start with an x and then a bar, and that says x such that, and then we put the inequality. X is less than 13/10. On the graph, we know 13/10 is a little bit more than 1, so we'll put it here at 13/10. Since it's less than, I want it to be an open circle, not colored in. Let me do this in another color. And shade to the left because it's less than. And for interval notation, that would be negative infinity up to 13/10, and because we didn't include it, we're going to put a parenthesis. So let's try that again. 4x minus 7x gives us negative 3x less than or equal to x plus 2. So just collecting like terms. And then if I subtract x, I get negative 4x is less than or equal to 2. And then I'm going to divide by a negative. So I'm going to get x is greater than or equal to negative 1/2. So again, if I give the solution, I'll give it all three ways. In set builder notation, that's going to be the set x such that x is greater than or equal to negative 1/2. On the graph, we would have negative 1/2, and because it's got the equal to bar, we're going to put a solid dot, and greater than would be to the right. And then the interval would be bracket negative 1/2 to infinity. So I find it very easy if you graph the inequality first to just look at the graph from left to right, and that will help you with your interval notation.